All right, so last time we got set up, we installed Eclipse, we installed Java, and then hopefully you're able to have this little program that says public static void main system.out.println hello world, and then you can go up and click the green play button and run it. So just a reminder, the way Eclipse is set up is we've got our package explorer over here on the left. The Package Explorer, that's where all of my projects live. And so specifically, I'm in this project at the top. And that's where my current editing file is. The thing in the middle, that's the editor. And the thing at the bottom, that's the console. So that's where the output goes. All right, so hopefully you're able to do this. So we're going to keep writing in this file and just practice some stuff, get used to Java. So you've probably noticed that we have written our code in this thing called public static void main string args. The main method, that's what lets us actually do the things that we want to do. So do you remember functions in Python? Yeah. And do you remember using like a main method in Python? Yeah, it's the same thing. We call it the main method. It has to have a certain, like this combination of things. Like it has to have the public static void bit. We'll talk about what all those mean. It has to have the string square brackets args because Java is picky like that. It's special. And so the code is only going to run if it has a main method. If it doesn't have a main method, then the code won't run. And this will hold true for pretty much every piece of code that we write in this class. Okay. So in Python, when you print something, you probably just said, go to a new line, you probably just said print, and that's it. And then when you print, moreover, you could use double quotes. You could say, you could use double quotes, or maybe you could use single quotes. Java doesn't like that. So for Java, when we want to print, we have to say capital S system.out.println. We don't have to choose println every time. There's different possibilities. So I'm going to take, I can say whatever I want. And try a few different things. So here I've got two print statements. So hello world, and I can say whatever I want. If I run that, and it asks me to save, then it prints them on two separate lines, right? Hello world, I can say whatever I want. If I removed the ln, then if I run it, it doesn't, so the ln is acting like it has a secret enter key at the end of it, where if I have ln, it'll say hello world and then insert a new line, and then the next thing you print shows up on a new line. If we don't have that, then whatever we print next just gets smushed right next to it. So that's print. If you ever experimented with like the end setting in Python print, that's what this is kind of like. It's just we call different functions to get the same behavior. There's also printf, which is, if you're familiar with like f strings in Python, that's kind of how this one works. So let's say, let's make that println. Let's do a printf. System.out.printf. And then And then D is for integers. And so the way that we say for printf, we say like we have certain placeholders where we say in our string, %s means this is a string's going to go here. Something of type string will go here. %d is saying something of type integer will go here. And so I want this to be, so class is my first one, and then 222 is going to be the second thing. So hello, %s, this is CS %d, and then I give it class and 222. Let's see if it works. And then it just inserts that information right there. So this is useful if you've got variables that you want to print. The other way to do this sort of thing, like let's say I have this as a separate variable, system.out.println. You can also what we call concatenate strings together, where we use the plus operator to put them right next to each other. So this is a really overcomplicated way of doing what we do here. And something that this shows us is that when we have printf, it doesn't automatically end a new line after we did that. So if we wanted there to be a break between CS222 and hello, then we have to insert it ourselves, and we do that \n. So once I run that, then this hits enter for us, and we're on to the next step. I will say I forget all the time what all the options for printf are. If you're confused by what the options for printf are, here's what I suggest. So there's the AI version, which I think has a pretty good overview of how it works. If you're not sure whether or not to trust it, we can scroll down. W3 Schools is typically pretty good. Another university, also a good reference. So I've clicked on that one before. And so this one tells you, here's what options you can put in. Okay. So just print leaves us with no break between the next thing we're going to print. Printf does formatting for us. Println is equivalent to just your normal print statement in Python, and that adds a new line at the end of it. You may say, I hate typing that out. So do I. It's long, it's annoying. There's tricks to make it shorter. So in Eclipse, which we're using, you can type sysout and then control space. This is the same for both Mac and Windows. So not command space, but the actual control key. So if I type sysout and then the control key and space, then for me, it auto-completes. For you, a pop-up might come up of, do you want system.out.println? And then you can either click on it or you can hit enter and it'll auto-fill that for you. So again, that's sysout and then the control key and then space. If you're in VS Code, you can type sysout and it'll bring up a snippet and then you can click or press enter and it's the same kind of thing. So that makes it easier. All right, so we're gonna work with some variables. If you're coming from Python, chances are you know the kind of stuff on the left, right? Where you can have some variable x equals 5, greet equals the string hello, the number equals 6.4, something like that. And in Python, that's all fine. Perfectly well and good. X happens to hold an integer, greet happens to hold a string, number happens to hold a float. But we can also move them around. We can say X was an integer, but now it's 6.5, it's a float. And Python just rolls with it. Greet, it was a string, but now it's 5. Number was a float, but now it's a string. In Python, that's fine. In Java, thumbs down. So we can't change variable types without saying anything. Moreover, we need to declare to say, I have a variable and I need to tell you what kind of variable it will be. What kind of information will it hold? And the way we do that is we need to say, here's the type name and here's the variable name. So it has to look like this. And what it's doing under the hood is it's assigning a space in memory that says, okay, variable name is going to live here, but I need to know how much space to allocate for this variable. So I need to, if it's an int, that's a different amount of space than if it's a string or something else. So let's say I want to declare something. So to say that I'm going to have a variable called x and it's going to hold an integer, I say this. So int is that type and x is the name of my variable. And it kind of helps that Eclipse, like, it knows what an int is, and so it turns pretty colors. So that's declaring. Then, so once we say, here's what kind of variable this will be, then we have to actually give it some data. And that's called initializing. And so this bit is declaring, where we're saying we're going to have an integer called I, we're going to have a character char called C, and a double called D. And then initializing is just basically what you're used to, where you have variable name equals the value. So let's say, so we have int I, char C, what was it, double D. And then later we can initialize where we say I is equal to 4, C is equal to S, and D is equal to 1.2. That's not 1.2. There we go. So we can do this separately. So this is sometimes useful if you know you're going to have a variable, but you don't know yet what it's going to be. Or you could do it all in one line. So if I know I'm going to have a variable x equal to 5, I can just do that all in one line. I don't need to split it up. So here we said we declared I and then initialized it separately. We can also just do that all at once. Okay. Yeah, and so this is us doing that all in one line, where instead of int I and then I equals 6, or char C, C equals S, we can say char C equals S, just all at once. And this is only needed the first time that you use that variable. So if later I decide to go and say int x equals 7, I am getting over here on the left-hand side. Let's see. I tried to have zoom. Okay, so over here on the left-hand side, there's the x, and we've got this squiggly line. That means that there's an error. And so if I hover over that, it says, nope, that's not going to work. Duplicate local variable x. And so what that means is I've tried to reserve space in memory for x 2 times, but they have the same name. And so we only can have our variables have to have unique names. And so it's like I have a spot for x and you're trying to make me reserve another spot for x. I don't know what to do with that. So if we're trying to just reassign x, we don't need the int. We can just say now x is equal to 7. So let's see. Okay, here's something that I see a lot of new students do is if we have, so let's say I've done something wrong, I have this error, but then I fix it. Sometimes, so right now the error went away, but sometimes the error doesn't go away. Sometimes I fixed it, but it's still there. So make sure that you save the file after you think you fixed an error, and then usually the error message will go away. Okay. So in terms of variable names, it's typically from what you remember with Python. There's some reserved words, but if you type those, then it'll turn different colors. So that's a pretty clear indication. Pretty please for variables, start with lowercase letters. Then after that, capital letters, underscores, numbers, those are all fair game. Uppercase, starting variables with an uppercase letter is reserved for something else. And I'll tell you the something else is what we call classes, because we started this class with a capital H, and that's the convention in Java. So normal variables that we use in the program, so like I could do int y equals 2, and then it doesn't tell me that I've made an error, but this is a Java standard. So we want just ordinary variables to start with lowercase letters. And then we can have 2, 3, 4 underscore, and we can name it whatever we want. Okay. All of the statements that we have in Java, all our code statements, all of our sentences need to end with a semicolon. So all of these things end with a semicolon. Certain things you'll notice, like for loops and if statements, don't. But any regular code statements have to end with a semicolon. So like if I delete semicolon here, then it's going to give me an error. In this case, it's a very helpful error telling me syntax error, insert semicolon to complete statement. Sometimes if the code is more complicated, it's not going to know that that's the issue. So double check if that's happening, especially as you get started with Java, because you need semicolons. The other thing I don't think I've mentioned so far is, so right now Eclipse is formatting this code for me really nice and prettily. In Python, the indentation matters. Like you have to have 4 spaces or tab. In Java, it doesn't care about that. So we could have, let me put all of these on one line, and that's totally fine. We could have this entire program just on one line, and that would be technically okay. Not readable, but okay. So indentation doesn't really matter in Java. What matters, why it indents, is because for readability. So if you're ever in a case where you're like, man, this does not look good, I can right click. And I think so if you right click on your code, a whole bunch of options show up. The ones that I usually look for are somewhere around like quick fix, source, and refactor, those three options. In this case, I'm going to go to source and then to format. Is that gonna, and then, yeah, so once I did that, it kind of moved things around, and all that code that I had on one line, it split it up into separate lines. So if the formatting ever looks weird, or maybe you're missing like a curly bracket and you need to figure out where, try hitting format, and then that can clean things up and kind of show you where you could be missing it. Yeah. There's also, so indentation doesn't really matter. White space doesn't really matter. So I can like, I'll say string s is equal to this is my string. And that's not indented. That's perfectly fine. We've also got curly brackets, which denote the scope of what we're in. So up here at the very top, we said this is a public class called Hello World. And we say everything in the curly brackets after that is going to be in the class. And then in the class, we've got a method called main. And then after those curly brackets, everything is going to be inside the method. And so that's the closing bracket for the method. That's the closing bracket for the class. So in Python, we had indentation, which shows scope. In Java, we have curly brackets. No, don't delete it. Curly brackets show scope. To make a comment, in Python, it was the hashtag or pound sign. In Java, I think we'll get into this in a little bit too, but we have two forward slashes. I never know the name. They're the ones underneath the question mark. So if you type two of those, then everything after that on this line will get ignored. Okay, so let's talk about those primitive types. So in Python, so I'm kind of using Python because that's what we cover in programming 1. So in Python, we have types called an int. That's pretty much the same. We've got a float, which is a decimal number. We've got bool, which is true or false. And in Java, we also have the notion of a character, a single character. There's not really that notion in Python. So in Java, we do have ints. We also have other things. So we've got bytes, shorts, ints, and longs. For decimal numbers, we've got floats and doubles. For true and false, we also have Boolean variables. We call them Boolean and not bool, and we spell them differently. So whereas in Python, you had capital T true, capital F false, in Java, we have lowercase t true, lowercase f false. And you'll see it if we, like if I have Boolean, I'll just call it var, and I try to say capital T true, it's going to say true cannot be resolved to a variable because it doesn't know what that is. So if then that's usually my cue to remember, oh wait, that's not how you spell true in Python or in Java. If I make it lowercase t, then that fixes the problem. Again, pretty colors, that's what we're working towards. If it turns pretty colors, then chances are you're on the right track. Okay. I don't think I have text for this, but there's a bunch of options here, and there's a bunch of options here. Why is that? The difference between all of these is the amount of storage space. I don't remember off the top of my head. Go back to Firefox. Does it have it here? No. Let's go to the Oracle link. So yeah, so the difference here, I can never remember the actual like numbers, but the difference between the byte, short, int, and long is just how much space has been allocated for that number. So a byte is 8 bits, shorts are 16 bits, ints are 32, long is 64. And similarly for floats versus doubles is 32-bit or 64-bit. And so we'll see later on in this course where we work with some really huge numbers, and eventually we get to the point where the numbers turn negative, and that's because we've overflowed to say, this number is too big for me to work with, so I've reset back to the beginning. And so that's a cue for us that we need to use a bigger kind of integer. Okay, so typically you'll see me using ints unless I'm going to be working with a super big number, then I'll use a long. And I'll typically work with double, but if the smaller versions work fine for you, then that's great. We've got Booleans, we've also got chars. And I have a small note that you can't really see at the bottom saying this might just show up on an exam. I would remember this. This PowerPoint is also available on Canvas. One thing to note that, so in Python, if we had quote C or just single quote C, so double or single quotes, that was the same thing. In Java, they are not the same thing. So, so this is a string. And if I try and replace the double quotes with single quotes, it's going to give me an error saying invalid character constant. And that's because single quotes in Java are reserved for single characters. So I'll undo that. And this is an example of a single character where there's just one letter in those single quotes. Okay, so yeah, so char is not the same as a string. In Java, single quote versus double quotes matters. A string is not in this table of primitive types. That's because primitive types are the simplest possible data types that Java has to work with. And string is a little bit more complicated than that. So we call string a reference type. So there's primitive and there's reference types. They're two separate things. And we'll talk about that in Unit 2. So we've got primitives. Those are the basic building blocks. And then reference type is anything else. If we're working with reference variables like strings, that we declare them in a similar way. It's just that the type name has to be capitalized. So like int is all int, char, and double here all start with a lowercase I, lowercase c, lowercase d, but a string starts with a capital S. So if I tried to make it a lowercase s, it's going to give me an error saying string cannot be resolved to a type. So string is a special type, and that starts with a capital letter. All reference types will start with a capital letter. Okay, questions so far? Okay, I need to fix the animations for that time, for that one. So you covered loops before. What kind of loops are there? For loops and while loops, yeah. So that's, yeah, I need to fix that. Nope. All right, there we go. So in Python, we have something like for I in range 10 or for I in some array. And then you can do something indented. In Java, we're going to do the same exact thing. It's just going to look a little bit different. So the way we get there is we have to understand what are the basic steps of a loop. And so this is true both in Java and in Python. Python kind of just hides this information from you, but it's still there under the hood. So the basic steps of loop are we need to initialize to say, where are we going to start? So if we're counting from, let's say we're printing the numbers 1 through 10, we have to start somewhere. And so we want to, this is the initialization step where we say we want to start at 0. For Python, we just assume that if I say range 10, I'm going to start counting at 0. But in Java, we have to explicitly specify that to say I'm looking at integers and I'm starting at 0. Then there's the condition step. So there's where do we start, initialization, and then the condition for when do we know that we're done. And so that involves, I want to print the numbers 0 up until 10. So I say I less than 10, that's when I want to stop. So that's the condition. And then we've got update. So how do we progress as we go? So in this case, we want to change everything by 1 each time. So for range, it does that automatically for you. It says, so you just input, here's where I want to stop. But for Java, we need to specify to say, here's where I start, here's when I'm going to stop, here's how I update each time. And so that's what goes here. So we have the initialization, we have the condition, and we have the update. And so this starts with the word for, just like in Python. And then we're going to need parentheses. And in the parentheses, go all 3 of those steps. So first we've got the initialization, then a semicolon, then a condition, semicolon, and then the update. Then we close parentheses, and then we've set up our loop. And now we need to actually give the code that's going to happen in the loop. And so we have the open curly brackets and then whatever we want to do inside the loop. Okay, I've got some, so let's try that quickly. So we'll do a for loop. So I type the word for. I can have a space here or not, doesn't matter. I'm going to have my initialization. So I'm going to say int I equals 0. And I think it's going to complain at me because I have a duplicate local variable I. And that was up here. So, if I ever come into this situation where I'm like, I could just delete and just call this J, but then I have to call that J as well. That's fine when there's only 2 instances of it. But if I've got more than that, I can I can select this variable, right click on it, and go down to refactor, rename. And if I do that, then I'll call it J instead, and then hit enter, and it changes it for me. So again, that's right click on the variable, go down to refactor, rename. And then you can type whatever you want and it changes it. So that's super useful. I love doing that. Okay, great. We have a long integer name. Okay, so once we do that, then that frees I up for us to use in the loop. Then we need, so we've got the initialization. Now we need the condition. As long as I is less than 10. And then we have the update where we're going to increase I by 1. And then I just want to print the number as we go. So I can do sysout and then control space. See, this time it didn't autofill. So that pops up. Then I can either click on it or I can just hit enter. And there we go. So let's print I. I'll save it and run it. Then it prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hooray. Okay. So the condition so remember if statements and stuff where you have to give it some logical condition? That's what we're looking for here. So the condition is something that's either going to be true or it is false. So for us, the condition is I less than 10? It's asking a question. And the answer is either true or it is false. So when I is 2, is I less than 10? Yes, true. And if this is true, then the code inside the curly brackets is going to execute. So when true, the code inside the loop will happen. Let's say we get to the end and then we say I is equal to 10. Then we ask the question, is I less than 10? If I is equal to 10, no, because 10 is not less than 10. So that's false. And then the code in the curly brackets will not execute. And that's why we only go up to 9. So yeah, so when you see something like this, so like less than, is X less than 3? Is X, so the double equal signs is testing equality. So is X equal to 10? Is X greater than or equal to 4? And then again, the Boolean variables are spelled true and false, all lowercase. For update, we've got some possibilities. So in the first image, I just had I equals I plus 1. That's updating I plus 1 and reassigning it. You can also do I plus plus, which just adds 1 to I. You can also say I plus equals 1 or plus plus I. All 4 of these are doing roughly the same thing. These two have a little bit of a difference. I think there's a textbook exercise that kind of lays it out how this works. The difference here is the timing for when that addition actually happens, or no, when the assignment actually happens. And so let's take a second, because I've been talking for a bit. Turn to your neighbor. If we've got these steps, how would we change it to add by 2 or 3 or -1? How would we change? Some of them maybe we can't change, like the plus plus, but some of them we can. How do you do that? Go for it.
I would guess, and maybe if you have more plus it than two. Instead of one. And then if you do like 10, it'd be nine. So maybe just. I'm guessing you just replace the one. Again. And then the last one. Jack on the plus.
I guess, but.
Yeah, no, it doesn't add plus.
Or maybe you just have like maybe you do plus plus two, so you wanna add two every time.
Okay, what do we think? So let's take the first one. Can we change that to add by 2 instead? Yeah. There's a 1 there, make it a 2. So let's try I equals I plus. First, let's make sure that this works. And that does what we want it to do. We made it by 2. Then it's going to print 0, 2, 4, 6, 8. So we're going up by 2s. If we did plus 3, then it's going to give us 0, 3, 6, 9. And so we can just change that number. If we wanted to make it go down by 1, what's going to happen? Is everything going to be fine? No.
Well.
Okay, if this ever happens to you, this is going and going and going. The numbers are getting bigger. What do I do? In Eclipse, there's this little, when your program is running, a little red square shows up. And so this is currently running. I would like it to stop, and it says terminate. So if I click on it, then it stopped. So, and why did that happen?
We'll never reach.
Right. Our condition is not applicable for the action that we're taking. Right? We thought we were counting up to 10, but we're not. We're going from 0 downwards. Okay, what about the second one? Can we change that?
Add two.
So something like I plus plus 2?
Yeah.
So the plus plus operator is designed to add only 1 at a time. So we do that, then it gives us 0 through 9. Let's test out what happens for plus plus I. So it does the same thing. It gives us 0 through 9. But again, the textbook exercise is going to help. The difference between those is the order in which it happens. So plus plus is just designed for incrementing, so adding 1. There's also decrementing, which is subtracting 1, so that's minus minus. So plus plus and minus minus. So I plus equals, so if we wanted to change it by 2 or 3, the I plus equals 1 is just a shortcut for I equals I plus 1. So if we wanted to change it by 3, we can do that too. The plus equal operator, it works with plus, it works for minus, it works for multiplication. It also works for division. So all those operators, the operator equals, that's a shortcut for, let's see. So variable equals variable operator and then some number. So I plus equals 1 is equivalent to I equals I plus 1. And if we made that a minus, we put a minus there, or any of the other operators. So plus, minus, multiplication, division. Okay. So this is the bare bones of a Java for loop. We've done this and now, so it's the word for parentheses, initialization, condition, and update. And then inside the curly brackets, that's where the code to repeat goes. And I think so I also have like this note-taking packet that we've skipped over a whole bunch of it. Yeah. I will note that where are the semicolons here? So they're in this like inside the parentheses, right? So they separate the initialization, condition, and update steps. And I would also assume that there's semicolons in the statements for the actual for loop, because like if we go over here, there's one. Do we have a semicolon after the parentheses? No. Do we have a semicolon after the curly bracket starts? No. Except for when after a statement of code. Do we have a semicolon after the closing curly brackets? No. So in here is where the semicolons go. And with the actual code statements is where the semicolons go. And again, if you mess up, then I'm like, if I put a semicolon there, then it's gonna complain at me of like, I cannot be resolved to a variable. Why is that? My code's broken. It's because we've decided to end the for loop there and not actually do anything. So check for where your semicolons are if you're having an issue. Okay, once we've learned about those 3 steps, the initialization, condition, and update, for a while loop, we just move them around. So for a while loop, we've got initialization outside the loop before we start. And then we still have the word while. We need parentheses to put the condition in. And then the update step just goes inside the loop. So all those pieces are there. We've just rearranged the puzzle. Let's see. So let's do the same loop. I'll comment that out so we don't get all of that repeat. So let's do a while loop instead. So while something, my initialization has to go before we get into the condition. So I used I up here. Let's use J this time. So J equals 0. And so while J is less than 10, we can say sysout J. I wonder if I could use I. Let's check. So let's rename. So right click over J, refactor rename. If I name it I instead, no errors. So what does that tell you about what happened to I? So earlier I said you can't declare a variable with the same name twice, but I'm doing that. How come? Turn to your neighbor.
There's only call.
So I guess those are declaring instead of
Integer I. I I just not really sure, so.
Okay, so yeah, so it's a matter of scope, right? So when we're inside the for loop, we know what I is. I is an integer, and we're incrementing it with each round of the for loop. When we're done with the for loop, we don't need I anymore. We erase it. We've forgotten about it. We can't access it anymore. And so that means once we're here, we can redeclare it. We can say, I want a variable named I. And since we've erased the old I, there's no other variable called I. It's out of scope. So we can make it here. Note that if I move this, so I'm about to do something super cool. I'm going to move this line of code up above the for loop, but I'm not going to cut and paste it. I'm going to hold the Option key on my keyboard while my cursor is on this line. And I'm going to do the up arrow key. So you can move by holding the Option key, or I think on Windows it's Alt. You can move something up and down, which is super helpful. So if I move it up before the for loop, now I is in scope. And so I can't redeclare it here. So if this is ever the case, then if I forget about declaring it again, and I just say, I've got the variable I started at 0, and then go forward. That's totally fine. So it all depends on what's currently in scope. Okay, so I'm going to move this back down. Option. And Windows should be Alt and arrow keys. And this works. I know this also works in VS Code. I think it might work in Colab. I'm not totally sure. But yeah. Okay, so back to our while loop. So we've got our initialization, we've got our condition, we've got the code that we're going to repeat. So let's go for it. Oh no. What have I done wrong? Yeah, I forgot the update step. It happens to me every time. And so let's do 5 plus equals 1, or let's do 3. So if I put it right here, I expect to get 0, 3, 6, 9. So if we do this, great. If I do this, what do you think we'll get? So the difference is it's up here or it's down here. Any thoughts? Yeah, sorry. Go for it. Right, because we start at 0, and then we're like, okay, now add it by 3. And so now I should be 3. So what are we going to print? 3, and then 6, and then 9. I agree. Oh. And it also prints 12. Is that against the rules? No, why not?
So that is 9, it's less than 10, you go through increments to 12, then.
Exactly. So we're at, let's say we're at 9, we print 9, then we go back to the beginning of the for loop. And we ask, is 9 less than 10? The answer is yes. So we add 3 to 9, now I is 12. And then we print 12. After that, so there's that last step of going back to the condition and saying I is 12. Is it less than 10? And the answer is no. False. And so then we stop. So for loops and while loops, they're both ways of repeating code. It's just structured a little bit differently, but we have the same building blocks. So as long as you're clear on that initialization, condition, and update, then we're good to go. All right, now let's talk about logic. So for logic, when you did some like if, else, if, in Python, it looked kind of like this, where you have the word if, and you have your condition. And if you wanted, so you've got if and else, and you deal with that with semicolons. And then if you wanted to have an alternative path, you can have elif for else if. And for logic, you use the word and, or the word or the word not. So we have all those things, we just call them differently in Java. So in Java, the word if is also spelled if. Congratulations. The word else is also spelled else. The word elif for else if is spelled else if. So two separate words right next to each other. After the if or else if, we need the parentheses. The condition is going to go there. So it's like we need them right here and right here. That's where the condition goes. And then after the parentheses, we need curly brackets. So let's do the if and else. So I think I have a variable x up here. So we have if x is less than 4. What did I say? Small, mid, and big. So we'll say it's small. Else if, actually I'm gonna leave else if for now. We're gonna talk about, because we need the and. So what did I say? X greater than equal to 4 and x less than 6. Greater than equal to 4 and x less than 6. So I'll leave it in there for now. And otherwise, we need to print sys out, control space, enter, big. Okay. I'm gonna comment that out. The way that I just did that without doing anything, on Mac, I do command and then slash, the one under the question mark, that comments it out. That works in pretty much every programming language editor. Yeah. So for Windows, I think it's control. So now we've got if x is less than 4, so x should be 5. If it's less than 4, it'll print small. Otherwise, it'll print big. So since I defined x as 5 earlier, I expect it to print big. Success. Okay, so the next case is I want to print like medium if it's between 4 and 6. The only problem is it doesn't know what and means. So we still have that functionality. We just need to call it something different. So in terms of logical operators, and in Python is spelled with 2 ampersands. So that's above 7 on the keyboard. So if I replace it with 2 ampersands, then that's and. If I wanted to do the logical or, that's the pipe character. I have picture for that. That's the one under the backspace or delete key. If you press shift, it's above the backslash. And so we call it the pipe character because it's just a line straight up and down. It's not a capital I and it's not a lowercase l. It's its own character. And then for not, in Python, you can use the word not. You could also use an exclamation point. In Java, we use an exclamation point to say not. So this is what that thing that we wrote in Python looks like in Java. So once we have this, we should be able to, so it does the same thing because we know what X is. But let's try making X different values. So if we make X equal to 2, then it prints small. If we make X equal to 4, then it prints medium. And then if X is 5, nope. If we make X 7, because that's bigger than 6, then it prints big. Where are the semicolons here? Yeah, so this is a code statement, and so we've got semicolons after every code statement. So after every print, yeah. But yeah, so they're not here. They're not here. And they're also not here. This is important. This is one of the things that I see trips students up a lot at the beginning. You have a question?
Yep, why do you have two signs?
That is equivalent to and. So to and is the word and in Python. So that's our logical operator. So we want to say, as long as X is greater than or equal to 4, and it's less than 6, I want to print medium. Other questions? Again, for here, formatting, like spacing doesn't really matter. I can have this if all on one line if I really wanted to. The reason I have it like this is mostly just for readability. Great, we answered that question. Hooray. All right. We're heading full tilt to be able to do lab 1 on Tuesday. So we have to talk about arrays. Do you remember lists in Python? Right? So lists, we have square brackets and we separate things by commas. And in Python, lists can be like a bunch of numbers, they can be a bunch of strings, or it can be pretty much anything we want. We can have a string next to an integer, next to a string, next to a decimal, and then we can have a list itself inside there, a list of single characters. So in Python, there was no restrictions for what kind of elements can go in a list. You might be guessing Java doesn't like that. So Java is very strict in terms of types. It's a strongly typed language, which means that we have to specify, here's what type this variable will hold. Here's what type of things are going to go into this structure that we call an array. So lists and arrays are linear. So they hold things in a straight line. So the idea of there's the first thing and then the next and then the next. So like hello comes first, and then this, and then is, and so on. So you'll see if you come to office hours and we've got questions about this, I'll draw like a box kind of like this on the chalkboard. What's that question? 14. Draw a representation. That's just a box. So here's an example I have where, let's say we've got a bunch of candy, where we've got Rolos, M&Ms, Twizzlers, Milky Way, Skittles, and so on. And so this is our bag of candy, where really it's like if we've got a long cardboard box and we have different spots. And so we put the candy in the box. So that's kind of what we want in Java. But in Java, there are something called lists, but they're a little bit more advanced. We'll look at them probably next Thursday. But the simplest way we do this is lists. When we call them arrays, which is basically the same thing. It's still this linear structure. We just call it arrays, and the way that we refer to it is a little bit different. So arrays are restricted to only having one type inside. So if we've got ints, we can only have ints in there. If we want it to hold strings, only strings get to go there. And so normally we have the type name and then the variable name. It's a little bit different for arrays. So for normal variables, we have declaring and we have initializing. For arrays, we have declaring, allocating, and then initializing. So allocating basically means I'm actually setting up all this space in memory. So we can declare and say, I'm going to be an array of ints called ARR or something. Or let's say A. I'm going to be an array called A. And I'm going to hold ints. But there's no actual spot reserved for me yet. It's kind of like if you're like, I'm going to go on a trip and I'm going to go to this city. But you haven't actually made a hotel reservation yet. So allocating is when you actually go and make that reservation, where you say, okay, I need the new keyword, and here's the type of thing that's going to live in this array. Here's how big it's going to be. So that's going to the hotel and saying, I'm staying for 2 nights at this hotel. So we can do it in separate lines or all in one. So let's try that. So the other difference that we have here is there's these square brackets that live after the type name when we declare it. And we've got the square brackets where the size goes when we allocate it. So I've declared I'm going to have a variable called A. It's going to be an array. The square brackets can kind of go anywhere. I don't think they can't go before the type, but they could go after the variable name. So it's not picky on where that goes, as long as it's here somewhere to say, this is going to be an array. And then we need to say, let's say we're going to hold 3 ints. And so this is allocating, where we've made our reservation to say, set aside a new block for 3 ints. So declaring and allocating. We can, similarly to declare and initialize, we can do it all at once. We can do it all in one line. Where we just, after the variable name, we say equals, and then we have this part that's on the right-hand side of the equal sign. So let's say we want to have an array of doubles, let's say 10 doubles. So we have the type, that's double. We have the square brackets here somewhere. Then on the right-hand side of the equal sign, we have the new keyword. We have reminding, here's the kind of thing that's going to live in this array. Here's how many spaces I want. So declaring an allocation. The reason we need to specify the size is that they have limited spaces in memory. This is also true for Python, but it kind of glosses over these details for you, where here there is a limit and we need to specify how many spots we're going to need here. So we need to allocate. And that way we only are going to use the spots that we actually need. If we end up in a space where we've filled up all of the spots and we need more, we need to do a process called reallocation, which is where we make a new array that's bigger, copy everything over, and then use that new version. So that'll be a problem for lab 2. So let's say we're working with a candy box and we have some type candy that we're going to use. And so we declare it where we say this is the type candy. We have our square brackets to say this is going to be an array. Our variable name is candy box equals new candy 10. And so that gives us enough space for all of our pieces of candy. Another way to get there, so let's say, so once I do this, then I can actually like say A0 is 1, A1 is 2, A2 is 3. So like what you're used to with indexing lists in Python also works, where we start counting at 0 and we use square brackets to reference that index. That all works the same. But if we want to have, let's say, an array where I know I want this to be 1, 2, 3, 4, 5. It's always going to be 1, 2, 3, 4, 5. I don't want to have to go through the process of allocating and then setting all these variables. I can just use curly brackets and say 1, 2, 3, 4, 5, and that's it. And that's gonna not be happy about because I've already named it something, so let's call it A2. So that's another way to create an array and give it some values. So it needs curly brackets. The things that you insert are separated by commas. The whole thing ends with a semicolon. And you can't change the size if you forget something. This also matters for regular arrays too. Okay, so we've got a little bit, let's see, how much time do we have? Okay, we're doing good. So work with your neighbor and figure out how to declare and allocate an array of integers that's initially 20 spaces large. Go for it. All right, did we figure it out? Yeah. Tell me what to type. Anybody? Call it out.
The
Hooray. The issue here is that I already have a variable named C. You can figure that out by hovering over it, and it says duplicate local variable C. So I don't know if I add a number to it, make it C2, that fixes the problem. Great job. Okay, so in terms of how we access the things in the array, there's a difference between the indices and the items. So two words that both start with I. But it's the difference between if this is my candy box and there's a difference between the seventh thing, like I want to go to spot 7 versus the actual Three Musketeers bar, right? So going to spot 7 is different than grabbing the actual Three Musketeers. So we return them by item number, which is the index. So the fourth thing in my candy box is the Skittles. So again, we start counting at 0. And so it's 0, 1, 2, 3, 4. And then we get the actual Skittles item. So the number is the indices. The actual candy is the item. So I've got another activity for you. So for the array that you made, I want you to try and use a for loop to assign those values. So remember so this is assuming that the array is named ARR. You can name it whatever you want. But do this. And then after the for loop, see what happens if you try to access different indices. Go for it. If you're confused, turn to your neighbors, see if they know what to do. Are we feeling stuck? Okay. Someone someone have it? Tell me what to write. I think I have I defined, so I'll say I equals. Open curly brackets? Great. Yeah, let's call it C2. Awesome. Okay, let's do that and then this may not work. So we do that. Yeah. Okay. So what happens if you try to access index 0? So let's try C2 at index 0. I'll just print that information so that we see what it is. Notice I've tried to just print C2 as it is. I know in Python you can do this where you can just print a list and it'll format it nicely. In Java, it's a little bit more picky. And so we'll talk about how we can do that. But first, let's just print the 0th thing in our array. What are we expecting? 0, because we've said, so we start I at 0, and then we say C2 0 equals 0. So if we do that, it prints 0. Hooray. So we have assigned, so this part is, so we've declared it, we've allocated it, and then it's like, so continuing with like the hotel metaphor, it's like now we're actually staying there. We've gone to the room, we've moved our stuff in. So accessing the 0th element works. Great. -1. I know you could do this in Python. Does it work in Java? So it doesn't give me an error. But if I try and run it, it gives me exception in thread main at u1basics.helloworld.main. If you get red text showing up like that, that's an error. So it's errored out. It did not work. So in Python, you can use -1 to get the very last thing in the array. In Java, you can't. So you have to know how long it is. So you have to get like the length or the size of the array. So -1 doesn't work. 19. Show of thumbs up, thumbs down. Do we think this will work? Thumbs up. I agree. 19, great. What about 20? Thumbs up, thumbs down. Thumbs up, thumbs down. I think thumbs down. Yeah, thumbs down. And the reason why, so like for our candy box, if we try and access, so our candy box has 10 spots, but we've started counting at 0. So if we try and access spot 10 in the candy box, there is none, there's no candy there. Spot 10 doesn't exist. So that's why 20 doesn't work. And similarly, 43, thumbs up, thumbs down. That's like way out of range. So 43, while it doesn't give us an error, does crash the program. And it says index out of bounds exception, which is fairly descriptive, saying that our index 43 is way out of bounds for the size of the array, which is 20. Okay, so we've got 2 minutes left. So I'm gonna give you this spiel on lab 1. This is what we're gonna do on Tuesday. You're gonna come to class. I'm gonna split you up into pairs, and then we're going to work on this for as much time as we have. Labs are, the idea is that they're harder than class examples. So like the ones we just did, they're more like mini projects. So I give you a lot of the starter code and then you fill in the blanks. But they're gonna be easier than the homework problems. So the homework problems, usually you don't have starter code. You're starting from scratch. But for labs, I'm gonna give you some code. We're gonna use Git to, that's where all the code is hosted, so you'll get it from there. And we're running out of time, so I will go over this on Tuesday. Tuesday, we'll also have someone from the STEM Center come and talk to us at the beginning of class, so make sure you're here for that. Thank you for coming. I will see you next week.